Hello, geometry friends. Today we're going to talk about coordinate geometry, and we've been paused from that for a while. So we're going to start this off by doing some review of formulas you should already know, and then learning one new formula. So let's get started. So we're going to deal with coordinate geometry, and really coordinate geometry means geometry on a coordinate plane where you have, x's and y's and points and things like that. So what formulas should you know already? Well, you should know the slope formula. And notice I said slope formulas because there's a lot of different ways to write it. One of the ways to write the slope formula is y2 minus y1, except I wrote a 2 twice, y2 minus y1 over x2 minus x1. Or you could write that as delta y over delta x. Or if you want, you could also write that as rise over run. Whatever works for you in the situation that you are in, that's fine with me. A lot of students really like this because they can just plug in numbers and get an answer. I myself really like this middle one because I can figure out the slope in my head quicker than I can by doing the subtraction and worrying about what signs things end up being. But it's completely up to you. Now, why the heck do we use slope? Well, there's a couple reasons we use slope. Number one, slope tells us how slanty something is. But when it comes to geometry, it gives us more information than just how slanty it is. We want to remember that the slopes of parallel lines are equal. So if two things have equal slopes, then they're parallel. And the slopes of perpendicular lines are opposite reciprocals. And that shouldn't be a shock to anyone. All right, so slopes of perpendicular lines are opposite reciprocals, slopes of parallel lines are equal. So make sure you know that. Now, what about the midpoint formula? Well, the midpoint formula is in the middle. It's the average of the coordinates. And so what that means for the formula is you just add the x's and divide by 2, and then add the y's and divide by 2. Okay. Why do we use it? What does it do to a segment? Well, we use it to find a midpoint. It splits a segment in half. So why do we use it? I mean, to find the middle, I guess. I'm not even going to write that. But what does it do to a segment? It cuts it in half. And that's a pretty powerful thing. All right, let's do a little bit of practice of things that you've already done. So it says, number one, find the slope of the segment AB connecting -3, 7 to 5, 3, and the slope of CD. What do these slopes tell you about the segments? Okay, so if I want the slope of AB, I'm going to do this using that formula y2 minus y1 over x2 minus x1. And this is x1, y1, and that's x2, y2. So this is going to be 3 minus 7 over 5 minus -3. 3 minus 7 is -4. 5 minus -3 is like plus 3, that's 8. And then we really like to simplify slopes that make things easier on us. So -4/8 is -1/2. Then if I want to find the slope of CD, I'm going to do that one my favorite way, which is the delta y over delta x. So how do I do that in my head? I say, okay, what happened to y? Y went from -9 up to -3. So y increased by 6. And then what happened to x? X went from -5 up to -2. So x increased by 3. And 6 over 3 is 2. All right. Now, if I have a slope of 2 and a slope of -1/2, you can think of 2 as 2 over 1, and the -1/2 is -1 over 2. Those are opposite reciprocals. So I know that AB is perpendicular to CD because their slopes are opposite reciprocals. Not so bad. All right. Done with slope. Now find the midpoint of AB. Okay, just going to use the formula. So for midpoint, we add the x's, divide by 2, add the y's, divide by 2. So add the x's is going to be negative 3 plus 5. Add the y's is going to be 7 plus 3. So negative 3 plus 5 is 2. 2 divided by 2 is 1. 7 and 3 is 10. 10 divided by 2 is 5. And there's my midpoint. Cool. And number 3 says find the midpoints of A, B, and C, D. Whoops, Mrs. Vibber made a typo that I just realized, so let's fix it. Find the midpoints of A, B, and C, D should say AC, my bad, and BD. Pardon me, so fix that. All right, so let's find the midpoint of AC. Well, A is the point negative 9, negative 1, and C is the point 1, 5. So if I want the midpoint there of AC's midpoint, I would add the x's, negative 9 plus 1, add the y's, negative 1 plus 5, and that's going to be negative 8 halves, which is 4, and 4 halves, which is 2. So that midpoint is negative 4, 2. So if I want the midpoint of AC, I'm going to add the x's divided by 2, add the y's divided by 2. So let's see. A is negative 9, negative 1, and C is negative 1, 5. And so if I add the x's, I have negative 9 plus negative 1. And if I add the y's, negative 1 plus 5. Those both get divided by 2. So I have negative 10 halves, which is negative 5, and 4 halves, which is 2. And I'm going to plot it just to make sure I've got the right point. Now, full disclosure, I edited this video because when I did this first, I got the wrong midpoint. And I didn't want to waste your time having you watch me do something wrong, so I did edit it out. But I am going to take this time to tell you it's okay. I make mistakes too, but the way that I know when I do is because when I'm dealing with graphs, I always try to plot the points or make sure that the answers I'm getting make sense. And that's how I caught it. All right, so there's AC's midpoint. Let's do BD now. So BD's midpoint. Let's see, B is negative 9, 4, and D is negative 1, 0. So negative 9 plus negative 1 over 2, 4 plus 0 over 2. Hey, that's going to be negative 5, 2 again. They have the same midpoint. What does that mean when two segments have the midpoint? We know that they bisect each other. So I now know that AC and BD cut each other in half. Whoops, too many lines. There we go. Ta-da! All right, so there's the review. There's slope and midpoint. Now let's get to the new stuff. We are going to talk about finding the length of a segment. There are 3 ways to find the length of a segment, okay, or the distance between 2 points. Distance and length, same thing. There are 3 different ways to do that. Option 1, you could just count the boxes, but you'd only count the boxes if it's horizontal or vertical, because then you can count them. If you can't do that, you can draw in a right triangle and use the slanty line as a hypotenuse. And if you don't want to do that, you could use the coordinates in something called the distance formula. So I'm going to show you all those different examples, and then you can use the one that makes the most sense to you. So number 1 says, find AB and CD by counting. By the way, please remember that when you see AB without a segment over it, it means the length of AB. So if I want the length of AB, it's 1, 2, 3, 4 boxes. And if I want CD, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 boxes. So AB is 4, CD is 12. Fantastic. All right, number 2. Find AD by drawing in a right triangle and using the Pythagorean Theorem. Okay, so AD is this slanty line right here, so I can't count it. But what I'm telling you is what we can do is draw a right triangle right here on the graph and say, all right, this would be side C, the hypotenuse, and I don't know what that is, but I know that the legs are 1, 2, 3, and 1, 2, 3, 4. So I can say 3 squared plus 4 squared equals C squared, which means that 9 plus 16 is C squared. 9 plus 16 adds to 25, but that's C squared. So to solve for C, I have to square root it. So I get C equals 5. Cool. That's 5 units long. Okay, and then number 3 says find BC by writing out the coordinates and using the distance formula. Okay, well, what's the distance formula? It's this. All right, your distance formula is x2 minus x1 squared plus y2 minus y1 squared, all square rooted. Or you can think of that as a delta x squared plus delta y squared, because really what you're really doing is finding your change in x and change in y. All right, so why does that make sense though? Well, because that's what we just did in the Pythagorean theorem. That delta x piece is really how far I went over left and right in my right triangle. And the delta y piece is how far I went up and down to make my right triangle. And then we squared them, we added them, and then we square rooted them when we were done. So the distance formula is really a formula to bypass the Pythagorean theorem if you don't want to or are unable to draw a right triangle on a picture. All right? Okay, so, shut up, Mrs. Weber. Let's actually get this done here. All right, what are the coordinates of B? B is 0, negative 3, and C is 5, 1. So I have 0, negative 3, and 5, 1. So if I want to use the distance formula, I'm going to do x2 minus x1 squared plus y2 minus y1 squared. And minus a negative becomes plus. Okay. Now, you're going to put this in your calculator, but you're going to do it without the square root symbol. And I know your calculator looks different than mine, but they're close enough. So just roll with me here, all right? You're going to put this in your calculator, and you're going to be careful how you do it with the parentheses. That way you let your calculator figure out the answer for you, and you don't have to worry about when do I square it or what's negative, what's not. Sure, I apologize. I have a sleepy day today. 5 minus 0, 1 plus 3. Okay, so I have 5 minus 0 squared and 1 plus 3 squared. Notice I did not put the square root in there. Okay, I did that on purpose. And I got 41. So then I'm going to go back here and say D is the square root of 41. So BC is whatever the square root of 41 is. And if I want to know what the square root of 41 is, I can, figure that out. It's about 6.4 units long. Is that what that says? Yeah. Okay. Ta-da. Now, again, I want to show you the way that I do it because I find it a little bit shorter. I don't like doing the minus and the squared. I always feel like people are going to lose a negative. Nothing wrong with this formula. It's great. You can use it. Or you can use my shortened version, delta x squared plus delta y squared, where we do the same thing, but we do a lot of it in our head. So if we want to use that other formula, delta x squared means how much did x change? Well, x went from 0 to 5, so x increased by 5. Delta y squared, well, y went from negative 3 to 1, so y increased by 4. And then I just have to do 5 squared plus 4 squared, which is again going to be 41, but I just find this a little bit quicker for me, and I don't worry about ever losing a negative sign. All right, practice again by finding AC using the distance formula. All right, so then I have to write down my coordinates of A and C. So let's see, A is the point negative 4, negative 3, and D is negative 7, 1. Negative 4, negative 3, negative 7, 1. So then the distance is going to be either with the distance formula, negative 7 minus negative 4 squared, which will become pluses, plus 1 minus negative 3 squared. Change those to pluses. And then type that into the calculator. So I have negative 7 plus 4 squared plus, and then what was the other part? 1 plus 3 squared. And my head's in the way. 25. So I get d is the square root of 25, which is 5. And again, if you want to see it with Mrs. Vibber's shortcut way, I shouldn't even say shortcut, shorter. It's not a shortcut. I can do delta x squared plus a delta y squared and say, all right, what's my change in x? Well, x went from negative 4 to negative 7, so x went down by 3. And then y went from negative 3 to positive 1, so y went up by 4. So then I just have to do negative 3 squared plus 4, squared. There we go. Squared. Ta-da! And I get 25 again. That's the distance formula, folks. So, find the lengths of all 4 sides of the given figure. Use whatever method you like best. Is it a parallelogram? Why or why not? So, this is how math often works, honestly, is you put a picture down, you draw something, you go, okay, that looks like a parallelogram. Is it? I don't know. Let's find out. So, let's find out if it's a parallelogram. How am I going to know if that's a parallelogram? Well, in a parallelogram, if I'm looking at lengths, if the opposite sides are equal lengths, it's got to be a parallelogram. So that's what I'm looking for. I'm going to do the distance formula to see if opposite sides have equal lengths. So I am going to do AD first, and I'm going to do AD using that Pythagorean Theorem method, just because I feel like it. So the Pythagorean Theorem method is the one where you draw in the right triangle, and you say, all right, this is 3 boxes. That's 4. So that would be C. So I would have 3 squared plus 4 squared equals C squared. 9 plus 16, which is 25. Square root it, I get 5. Okay, so this is 5. And while I'm at it, I'm going to draw another right triangle down here because it's small and not hard to draw. That's got a 3 there. 1, 2, 3, 4. That's got a 4 there. This is the same right triangle. So this has to be 5 for the same reason the first one was 5. All right, so I know AD is 5 and I know BC is 5. Cool. Now let's do the other ones using the distance formula. So D right here is negative 1, 9. And C right here is 5, 1. All right. So if I want to find the length of DC, I'm going to do the square root of delta x squared plus delta y squared. So negative 1 became 5, so x went up by 6, and 9 went down to 1, so I subtracted 8 for y. Calculator. 6 squared plus negative 8 squared is 100. So then DC is the square root of 100. And the square root of 100 is what times itself equals 100? 10. So I now know DC is 10. All right, and let's do AB now. So A is the point negative 4, 5. B is the point 2, negative 3. So negative 4, 5, 2, negative 3. And so if I do my distance formula, and again, I'm going to do it my way because I can, and I'm the one making the video. So, I get to make all the choices. All right. So AB, I got negative 4. Change in x becomes 2. That's 6 more. Let's see. 5 becomes negative 3. That's down 8. Hey, it's the same thing I had for DC. So AB is again going to be the square root of 6 squared. Not 6 squared. I already wrote that down. Square root of 100, which is 10. So let's answer the question. Is ABCD a parallelogram? Why or not? Yep, it is, because both pairs of opposite sides are congruent. There you go. All right, friends. So I am done with this video. And what I would like you to do is practice that problem set that starts with number 1 on the next page. And it's only 1 page. So yay. Do 1 page of a problem set and you are good to go. I hope everybody is having a good day and continues to do so. And we'll talk again soon.